Hello, my name is Charlie and this is Slime for Games Research and Development. This week, the main task was to create a branching algorithm to emulate the slime mold's searching patterns. Surprisingly, there aren't any papers on this aspect of slime mold, only the efficient networking between food sources after it is explored. So for inspiration, I started looking at different similar structures in nature, such as veins. I found this paper detailing how to create procedural relief veins. However, the technique it uses utilizes spread out growth hormone for the veins to move towards, so I had to find another technique. I then moved on to lightning, as the process is merely the attempted path of least resistance between 2 points. While I didn't end up using this algorithm, it helped refine the idea of how I would go about creating my own. One main hurdle I had to overcome is the translation of diagonal lines to a two-dimensional grid. For this, the Brazenham line algorithm was used to identify which pixels should be activated along the plotted line. With this algorithm in place, the results were encouraging. However, this algorithm was recursive, so it could only complete within one frame, which doesn't work for my task. I needed real-time traversal of my algorithm over multiple frames. To fix this, I used timers. This delayed the recurse call of the function by a set time, allowing the creation of a path over multiple frames, without having to store all the data in global variables to be referenced in the next tick of an update function. With this implemented, the player can watch the algorithm work in real time, if not with a hefty frame penalty. This was due to many overlapping branches, which was fixed by adding conditions which destroyed the branches if their destination was already part of another branch. The algorithm itself is a recursive branching algorithm. The algorithm simply chooses a random position around it and calculates if it's closer to the target than before. If it is closer, then it draws a line and moves to the new position, calling itself again. At any point along this path, it has a chance to spawn a new branch, which in turn can spawn their own branch and so on. However, with each new branch generation, the chance of the branch randomly dying increases. My algorithm can be called within blueprints, with many variables that can be adjusted for the optimum desired effect. By assigning new parameters, such as changing the start and target positions, I can make the algorithm crawl to any position the player chooses.